application. It's not like on Corba, as you were saying. It's like where you push around simple or like individual objects. It's more like you push a whole application to this, or components of an application. But it is very much like, so the one thing that it has in common with Corba is that it abstracts the interface and the implementation. And in this case, the interface is defined as a Java interface, and the implementation is just bytecode.
So is it like RMI ideal kind of thing?
It is similar to RMI, but the interaction between the we were actually thinking about this a long time ago. The interaction between the individual modules is a local object call. So it's not designed as that the individual modules can reside on different gateways. So they cannot, so it's just you have the object reference and you call it transparently. We tried actually we tried a way back to use RMI for this, because this would have been really great for RMI to make it even more transparent. There would have been some overhead in terms of cost, because it obviously is more, well, it costs you more the method call when you do it through RMI, even when it's local. But then the other problem is, the main problem why we dropped it is when you register a servlet with the HTTP service, for example. So this is like, okay, this is not really low-level information. So when the HTTP service has an interface that allows you to register an object as a servlet, and the servlet interface wouldn't allow us to use RMI because there would be callbacks in the other direction, and this would have failed basically with RMI. So this was the main reason why we had to drop it, and we were sorry about it because it would have made a lot of sense. So yeah, that's a good question. Yes?
As for the VMs, might that be Oracle OLE? Would that fall into that category?
I haven't tried it. Do they have their own VM implementation?
I'm not quite sure.
I don't know.
It emulates the look like machine.
I don't know if they have their own or if they use somebody else's.
I don't know.
Yeah. So, yeah, the other reasons for Java were it kind of prevents people from doing stupid things. It ensures integrity. It's actually a mature platform, and it's getting actually even more mature. So I must say Java for those applications, it has actually, in the beginning there was some problems, but now Java has matured quite a bit now. And there is a pretty wide developer community, because there is a lot of people who picked up Java to do desktop applications, and it's easier for them to write embedded applications than it is to learn about real-time operating system stuff and write embedded real-time operating stuff. That's nasty. And you have a large available code base. The problems that we ran into is, well, integrity, meaning it's not the model that we have with the OSGi applications. It's more a cooperative model. It reminds me always a little bit what Windows did back in the old days with 3.51 or something. As I said earlier, the isolation that we have right now is we use the class loader for different applications, and we keep track using Java 2 security. But it's not like, for example, an operating system process where you can make real guarantees and you can say, okay, this is only supposed to use up so many megabytes of RAM, and if it uses up more, then I can kill it. In Java, you can't really limit the memory consumption of anything. It's like, there's always more memory. You can always create one more object. And if one application misbehaves and, like, for example, allocates a lot of resources, this might actually start other applications. And you also cannot really force shutdown anything in Java. It's like you can kill a thread, but it doesn't mean that it really has to stop. It can always do something weird, override the finalizer, or do something funny. So the model is more a cooperative model. So although we said initially we want to deploy components from different manufacturers or from different sources, those components should be checked. guaranteed that they don't do anything nasty. The security that we use to isolate between different tasks is costs a little bit of performance, but that's probably worth it. Well, we have the overall performance overhead or performance cost of Java, which, well, with processes getting faster and faster, it's probably not as big an issue anymore as it used to be. We have been running this on 80 megahertz, 486 processors. The advantage is for those embedded applications, people don't expect the 20 millisecond response time. It's like stuff gets loaded through the browser anyways, and things are typically not as critical as on a desktop system. Size is an issue. I've addressed this earlier. We range somewhere in the 4 megabyte range. And lack of resource management. Again, it's not an operating system. Although Sun has kind of put many features of operating systems in there, they haven't done a particularly good job. So next, after this more or less general overview, I'll give a little introduction of the individual entities here. So the entities in the framework is obviously the OSGi framework itself, the OSGi environment. Bundles is one entity. So a bundle corresponds to a jar file. So this is like about the granularity of an application module. So a bundle is somewhere between a DLL file and an exe file, if we compare this to the known Windows world. Services are the interfaces between applications and between bundles. So in the known world, this would be, for example, the Corba interface description, or this would be the RMI interface. Filters, registry, it's LDEP-based syntax. There is a heavy use of events, so the framework, there is many events that the framework can generate to notify those individual bundles, and there is security mechanisms in the framework. So a typical environment looks pretty much like this, where we have the hardware, we have the usual driver operating system stack. On top of this, we have the virtual machine, and we have the OSGi framework. Which, just to put this a little bit in perspective, the OSGi framework itself is approximately 100 kilobyte byte code. So it's a decent sized Java application, but compared to the 2 megabyte for the Java virtual machine, it's actually smaller than shown here. And then the individual applications come in form of bundles, which are loaded and unloaded through the OSGi framework, and they can look up or publish services which are stored in the OSGi registry. Also, a bundle has access, of course, to the OSGi framework functions. It has access to the regular Java VM features, can open networks. There is no real restrictions on what a bundle can do, other than through the security manager. And then it can also contain native code and access the operating system. As I mentioned earlier, the goal is to have multiple applications to share a single VM, which is kept running. It's considered as almost like part of the operating system. It manages applications, specifically the life cycle, the packages, it handles security, and it also handles dependencies between applications. It provides a registry for services to collaborate. So it provides a service registry for bundles to collaborate by exchanging services. And it has an extensive notification mechanism. As I said earlier, events are very widely used. The other remark is that it's policy-free. So this means that there is no management policies or security policies as part of the framework, but those are extended as separate modules. So there is management bundles and security bundles which handle this. So this allows the framework to be as generic as possible. This is a very simple view on, okay, so the colors don't really come out. That's a very simple view of what OSGi framework would look like that has 3 bundles running. And in this graphics, a bundle is drawn as a circle, and then the triangular things are services. So For example, bundle B publishes one service, and bundle A interacts with the service by looking up the service. And well, bundle C publishes two services. So this is just a little bit the notation of how it looks like, and that's the interaction also between the bundles. Here again, to summarize, a bundle is like a Windows exit file. It's an application, but actually, I would say an application consists more of one or multiple bundles. It's not really defined, but I would say a bundle to me, is the smallest unit of delivery that you want reasonably to update or change later. A bundle can register 0 or more services. So a service for a bundle is like something that somebody can interact with. So a bundle that does not publish any service doesn't allow anybody else to interact with it. It might still be useful by interacting with other bundles and looking up services and using them. A service is defined as a Java interface and may be implemented by multiple bundles. Then we can use searches to find services registered by other bundles. So a bundle can look up other bundles by querying with an LDAP-like syntax. As I said earlier, the registry allows to annotate the object with strings. We can query in those. And the framework itself is only another bundle. It's the system bundle. So again, it's a jar file. The jar file is annotated with an extended manifest, which defines dependencies on other resources, and it also defines additional name, description, copyrights, and so on. And then it defines an activator, as we call the bundle activator, which is called to start and stop the bundle. So, okay, I don't know if this is on any slide. I'll just mention it here. Basically, the dependency between bundle is that in Java we have different packages, and as I said, a bundle typically has its own class loader. It accesses the classes that it brought with in its own jar file, but it can also access other library bundles. And so I've always talked about import and exporting services. We can also import and export packages in a controlled way. And if a bundle depends on another package, for example, there could be, say, the serial port package. It's not part of the standard Java environment. There is a bundle which implements a serial port, and it exports the package, whatever, javax.com. I don't know what it is, serial. And this exported package would be stated in the manifest of the exporting bundle, and everybody else who needs this bundle can state it in the import statement, and then this bundle can only be started after there is somebody found who is exporting this, so the dependency is satisfied. So those dependencies are actually evaluated before the bundle is started. And then starting a bundle, well, regular Java files or Java applications have a main class that is like just a standard interface, and you know when you write a main class, that's the first thing that gets called. An OSGi bundle needs a class that implements the bundle activator interface that allows it to start and stop. And the name of the class can be specified in the interface so that it's found. So we don't have a strong naming convention. It's just a class that we put in the manifest. And as I said, it can also act as a library, like a DLL file, and only export something and not be active. Yes?
How would you version control various bundles? So let's say in your example, the serial port bundle. So let's say the system currently has one bundle, and there's either an upgrade, or you may have two bundles that, through whatever dependency, may refer to different versions of that.
Yeah. That's an interesting problem that can arise there. So the standard how it works today is that if two